Question 16. What are the criteria for choosing a process for swapping out of the memory to the swapped device? Answer. The process's memory resident time, priority of the process and the nice value. Question 17. What do you mean by nice value? Answer. Nice value is the value that controls increments or decrements the priority of the process. This value that is returned by the nice system call. The equation for using nice value is priority equals recent CPU usage slash constant plus base priority plus nice value. Only the administrator can supply the nice value. The nice system call works for the running process only. Nice value of one process cannot affect the nice value of the other process. Question 18. What are conditions on which deadlock can occur while swapping the processes? Answer. All processes in the main memory are asleep. All ready-to-run processes are swapped out. There is no space in the swapped device for the new incoming process that are swapped out of the main memory. There is no space in the main memory for the new incoming process. Question 19. What are conditions for a machine to support demand paging? Answer. Memory architecture must be based on pages. The machine must support the restartable instructions. Question 20. What is the principle of locality? Answer. It's the nature of the processes that they refer only to the small subset of the total data space of the process, i.e. the process frequently calls the same subroutines or executes the loop instructions. Question 21. What is the working set of a process? Answer. The set of pages that are referred by the process in the last n references, where n is called the window of the working set of the process. Question 22. What is the window of the working set of a process? Answer. The window of the working set of a process is the total number in which the process had referred the set of pages in the working set of the process. Question 23. What is called a page fault? Answer. Page fault is referred to the situation when the process addresses a page in the working set of the process but the process fails to locate the page in the working set, and on a page fault the kernel updates the working set by reading the page from the secondary device. Question 24. What are data structures that are used for demand paging? Answer. Kernel contains 4 data structures for demand paging. They are page table entries, disk block descriptors, page frame data table, PF data swap use table. Question 25. What are the bits that support the demand paging? Answer. Valid, reference, modify, copy on write, age. These bits are the part of the page table entry which includes physical address of the page unprotection bits. Question 26. How the kernel handles the fork system call in traditional Unix and in the System V Unix while swapping? Answer. Kernel in traditional Unix makes the duplicate copy of the parent's address space and attaches it to the child's process. While swapping, kernel in System V Unix manipulates the region table, page table, and PF data table entries by incrementing the reference count of the region table of shared regions. Question 27. Difference between the fork and vfork system call? Answer. During the fork system call the kernel makes a copy of the parent process's address space and attaches it to the child process, but the vfork system call do not makes any copy of the parent's address space, so it is faster than the fork system call. The child process as a result of the vfork system call executes exec system call. The child process from vfork system call executes in the parent's address space. This can override the parent's data and stack, which suspends the parent process until the child process exits. Question 28. What is block started by symbol? Answer. A data representation at the machine level that has initial values when the program starts and tells about how much space the kernel allocates for the initialized data. Kernel initializes it to 0 at runtime. Question 29. What is page stealer process? Answer. This is the kernel process that makes rooms for the incoming pages by swapping the memory pages that are not the part of the working set of a process. Page stealer is created by the kernel at the system initialization and invokes it throughout the lifetime of the system. Kernel locks a region when a process faults on a page in the region so that page stealer cannot steal the page which is being faulted in. Question 30. Name 2 paging states for a page in memory. Answer. The 2 paging states are: the page is aging and is not yet eligible for swapping. The page is eligible for swapping but not yet eligible for reassignment to other virtual address space.